Now we are going to learn the transformer problem. So in the last class we have learned how to solve the transformer problem using 8 steps. So if we by heart those steps, then it will be easy for us to solve these problems. So normally questions will be asked like we need to find the overall dimensions of a transformer. So if the overall dimensions of a transformer is asked, then you need to find the width of the transformer, the height of the transformer, then the distance between the co-centers. So you need to by heart all the equations for single phase, three phase, core type transformer as well as shell type transformers. Okay, moving on to the problem. First question is determine the dimensions of core and yoke for a 200 kVA 50 Hz one single phase core type transformer. A cruciform core is used with distance between adjacent limbs equal to 1.6 times the width of core laminations. Assume a voltage per turn 14 volt, maximum flux density 1.1 Weber per meter square, window space factors, that is KW is equal to 0.32, current density is given as 3 ampere per millimeter square, and stacking factor is given as 0.9. In the question, if the stacking factor is not given, we have to assume as 0.9. So in this question we need to find the overall dimensions of the transformer. Overall dimensions of the transformer means we need to find the height of the transformer H, width of the transformer W, and the distance between the center capital D. Using the 8 steps which we discussed last class, it will be easy for us to solve the problems for the transformer. So first the basic equation is ET is equal to 4.44 phi m F. So phi m can be written as Bm into AI. So ET is equal to 4.44 F into Bm into AI. So in the question ET, voltage per turn or EMF per turn is given as 14. So substitute ET as 14 and F is given in question as 50 and Bm is 1.1. So from this equation it is easy for us to find the value of AI. So AI is obtained. Since the question given is cruciform, so AI is equal to 0.56 d square. From this equation we can find the value of small d. Okay. And small a is equal to 0.85 d. So we will get the value of a. In the question it is given as the distance between adjacent limb is equal to 1.6 times the width of core laminations. Therefore, capital D is given as 1.6 times small a. So substituting the value of a, we will get the value of capital D. Now the normal equation to find D is equal to small d plus WW. From this equation, it's easy for us to find the value of width of the window. That is WW is equal to capital D minus small d. So we got the width of the window as 0.1151 meter. Now for a single phase transformer, Q is equal to 2.22 Bm F AI AW KW delta in 10 raised to minus 3. So in the question Q is given as 200 kVA, Bm is given, F is given, AI is given, KW is given. KW is window space factor, that is given, and delta is also given. So from this equation we will get the value of AW. Okay. So next W is equal to capital D plus A. Okay, capital D, we know the value of capital D and we know the value of small a. So we got the width of the window. Now we need to find the height of the transformer. To find the height of the transformer, the equation is H is equal to HW plus 2HY. Okay, so for a single phase transformer, HY is equal to A. So we know the value of HY. Next, we should know the value of HW, height of the window. Okay, so from this equation, AW is equal to HW into WW. We will get the value of HW and substitute that value. Therefore, we will get the value of H. So the overall dimension is capital H, height of the transformer is 0.8016 and width of the transformer is 0.706, and we also found the distance between the core, capital D, as 0.43492. So this is a basic problem to learn the transformer problem, and with the 8 steps we learned in the previous class, it is easy for us to solve the problems on transformer.